Welcome to geometry class. Today we'll talk about indirect proofs. We do an indirect proof through something called indirect reasoning. Up until now, all the reasoning that we have been doing has been direct reasoning, typically reasoning from given facts to conclusions that are sound. Now we need to talk about indirect reasoning. In indirect reasoning, all possibilities are considered, and then all but one are proved false. When we do that, the remaining possibility must be true. Take a look at this example. Suppose someone comes up to you and says, hey, your brother's outside waiting for you. You go through the following reasoning process. You start by considering the fact that you have two brothers. So now we are left with the possibility of the brother outside being one or the other. The next thing you do is you remember that your oldest brother is living and is actually currently in California. So what do you conclude? You conclude that it must be your younger brother that's waiting outside. This is called indirect reasoning. We consider all possibilities and we exclude all but one. Notice when we did this in this particular example, we didn't have any evidence whatsoever that it was the younger brother outside. Rather, we concluded that it had to be the younger brother, not because we saw him, not because we heard his voice, but simply because he's the only brother who could possibly be out there. This is indirect reasoning. Proof involving indirect reasoning is called an indirect proof. These indirect proofs are as reliable, by the way, as direct proofs. They're just done in a slightly different way. In indirect proof, it's very important to remember before you get started that a statement and its negation are the only possibilities in any circumstance. What do I mean by that? Suppose I had a statement, it is raining outside. The negation of that statement is it is not raining outside. Those are the only possibilities. There's no third possibility that we could contemplate. It's either raining or it isn't. I am inside the building. I am not inside the building. Now, we can try to equivocate on those words and redefine what we mean by the building. But once we settle that issue, which building we're talking about, I'm either in it or I'm not in it. And that's always the case. Only two possibilities in that sense. And that's very important when we go forward in indirect proof because we need to be able to nail things down that way. How do we write an indirect proof? There's 3 steps. Step number 1, we state as an assumption the very opposite of what we want to prove. So if we want to prove that the building is white, we will start by assuming that the building is not white. If we want to prove that x equals 3, we will start by assuming that x does not equal 3. We'll start with the very opposite or the negation of what it is that we want to prove. Step number 2, we show that the assumption we made in step 1 leads to a contradiction. We'll look a little bit more at that in just a moment. Step number 3, once we find that step 2 led to contradictions, we will conclude that the assumption we started with had to have been false, and that the opposite of that assumption, that is the very thing we want to prove, must be true. We'll work through a couple examples. Here's the statement. It says, if x equals 2, then 3x minus 5 does not equal 10. We'd like to prove that statement using an indirect proof. How do we begin? Step number 1, we need to assume the opposite. Therefore, we'll assume that if x equals 2, then 3x minus 5 equals 10. We'll assume the opposite. The next step, the second step, is to show that our assumption in step 1 leads to a contradiction. How can we do that here? Well, the easiest way is just to do some algebra over here and see if we can solve this equation for x. So we have 3x equals 15. And then finally, we know that x is equal to 5. So we're left with the following statement. It says, if x equals 2, then x equals 5. Question, does that lead to a contradiction? Yes, it's a patent contradiction. It's obvious on its face. That can't be true. So our assumption led to a contradiction. What do we conclude then? We conclude that the only other possibility is true. If x equals 2, 3x minus 5 does not equal 10. So we've proved what we set out to prove. Let's take a look at another example. If triangle ABC is isosceles, then the measure of the base angles cannot be 92 degrees. First step, what do? Let's assume the opposite first. If triangle ABC is isosceles, then the measure of the base angles can be 92 degrees. Second step, identify a contradiction. It's a little bit less obvious. We need to do a little bit of geometric reasoning here, but if we had an isosceles triangle, and one of the base angles was 92 degrees, and that would mean that the other base angle is 92 degrees, you can see already that 92 plus 92 is 184. We're in trouble because we know that the sum of the interior angles of a triangle is always equal to 180. And that would suggest that x has to be a negative value. We don't measure angles with negative numbers, and so this leads to a contradiction. What does that mean? It means, by indirect reasoning, that this statement must be true. We proved it indirectly by assuming the opposite, showing that that opposite assumption leads to a contradiction, and therefore concluding that the statement must be true. That is how we reason indirectly in geometry and how we carry out an indirect proof. I recommend, as always, that you find some practice problems. Make sure you understand the concept. Make sure you work through it a few times to gain your confidence. And as always, if you have any questions, shoot me an email.